Welcome back, week 3, day 1. Today we're going to see the second method of solving a system of linear equations. In this case, equations with two variables, right? So we're going to see the second method. We saw already by graphing, we said it was not completely accurate because sometimes it is a fraction and sometimes it is a whole number. And the order pairs, when they're whole numbers, are easy to identify. But when they have a fraction, sometimes it's a little harder to identify the order pair. Okay, we had to practice with the previous classwork that you had to hand in by yesterday. So let's see what goes with the second method. Okay, so we're having two equations, just like normal. 6y plus 2x equals to 3, and 2x plus y equals to 8. We are going to use a method of substituting. Okay, meaning that you're looking for one of those two equations that has one variable, easier to leave it alone, okay? And then you're going to substitute whatever you got into the equation 1, okay? So we're going to call this equation 1. We are always going to call one equation 1, and the other equation, we're going to call it equation 2, okay? Let's see what variable in which equation is easier to leave completely alone in one side and positive. Kate. Okay, so we got 2y plus 2x equals to 3. Not that easy, right? And then we got 2x plus y equals to 8. I can leave the y on equation 2 alone easier. Kate. So I'm going to do that. I'm going to leave this y alone and positive in one side. So I have 2x plus y equals to 8. It is easier to leave this y alone because it's already positive and completely alone. So I'm passing this 2x to the other side with an inverse operation, which is a subtraction. And I'm having now y is equal to 8 minus 2x. Okay, last time. Okay, so we're going to have this as my new equation 2. Okay, this is the new equation 2. So I'm going to place an n in there, new equation 2. Okay, so what are we going to do now? We are going to substitute what the y is equal to into our equation 1. Okay, so what does that mean? It means that instead of using y in this equation, I'm using what y stands for in my new equation 2. I'm going to place it in blue. Okay, everything else will remain in black. So I'm going to have 6, and instead of y, I'm placing 8 minus 2x, okay? So parentheses, 8 minus 2x plus 2x equals to 3. So you see equation 2, I left the variable y completely alone. And then what that stands for, I replaced it into the variable y of my first equation. Okay, that's what I did. Instead of y, I placed what y is equal to. Okay, now I do the distributive property because I need to solve. And you see, we only have one variable now, that's what we were looking for. Okay, so we got 6 times 8, that's 48. 6 times negative 2x, that's negative 12x. Plus 2x is equal to 3. We simplify the like terms. Remember, this is like term with this one. So I go ahead and simplify, and I get 48. Negative 12x plus 2x.
Negative 10.
Negative 10x.
Negative 10x equals to 3. Now I need to leave the variable completely alone and positive in one side because that's best. So I can do a flip over and I can pass this negative 10 to this side positive, and this 3 to this side negative, and all at the same time. So I have 48 minus 3 equals to 10x. 48 minus 3?
45.
45 is equal to 10x. 10 is multiplying, passes to the other side, dividing. And I have 45 over 10 equals to x. Can I simplify the 45 over 10?
By 5.
By 5. Very good. And how much is 45 divided by 5?
9.
9. And how much is 10 divided by 5?
2.
2. So x is equal to 2. I found already the value of x. What is my next step? My next step is to substitute again, but now the value of x into my new equation 2. Okay, so instead of x, I'm using the value that I found. So I'm going to say, I'm going to do it in green. Y is equal to 8 minus 2, and instead of x, I place the value that I found, 9 over 2. Now remember cross simplification? I got a 2 in the numerator and a 2 in the denominator, so they cancel out, they actually become a 1. So I got that y is equal to 8 minus 9. Just because they're the same, and one is in the numerator and one is in the denominator, okay? I can cancel that out. And how much is 8 minus 1? Minus 9, sorry.
-1.
-1. And I found already my order pair. How many solutions this has? It has one solution. Why it has one solution? Because I got a value of x and a value of y. And the solutions are 9 over 2. Comma, -1. Always the x goes first and the y goes afterwards, okay? Always x comma 1. 9/2, comma, -1. If we graph this, our solution set, our solution will also be 4.5 comma -1, okay? Or 9/2 comma -1, because 9 over 2, that's 4.5. Okay, and that is the solution for this system. Do you have any questions? Is there any question whatsoever? No? Let's use another one. Let's do another one, okay? Do another exercise so you can understand it better, okay? Let's do, for example, these are not from the book, by the way. These exercises are not from the book. So we're going to be doing x minus 2y minus 1 is equal to 0. And the second equation is going to be y minus 5x plus 14 is equal to 0. Okay, so again, same thing. First to do is to call equation 1 and the other one equation 2. Then you choose one of the equations that is easier to leave a variable completely alone and positive in one side. So let's see, Fernanda, what equation would you like us to use, or which equation do you think it is easier to leave with a variable in one side completely alone? Equation 1 or equation 2?
I think probably 1.
Equation 1, okay. What variable would you leave completely alone?
X.
X, okay. So we're gonna do new equation 1. We're gonna do it in blue because it's in blue. New equation 1. So we got x minus 2y minus 1 is equal to 0. And we are leaving the x completely alone. So that means that this -2 should go to the other side positive. And also this one should go to the other side positive as well. So we are having now my new equation 1, x is equal to 2y plus 1. And that's my new equation 1. And now I'm going to substitute this value, this, in this x, okay? Because that's what x stands for. X is 2y plus 1. So I'm going to substitute that. So I'm going to say y minus 5, and instead of x, I'm placing 2y plus 1 plus 14. And that is equal to 0. I'm going to do the distributive property over here. And I'm going to have now y -5 times 2y negative 10y. -5 times +1
-5.
-5 plus 14 equals to 0. As you can see, I have like terms that I can simplify, the y and the -10y, and the -5 with the 14. I'm going to simplify that. How much is y minus 10y?
-9y.
-9y. How much is -5 plus 14? Which is -5 plus 14?
+9.
+9, right? So plus 9 is equal to 0. Now I'm going to leave the variable y completely alone and positive. So I'm passing it to the other side, adding. So I have 9 is equal to 9y. Now I leave the y completely alone. So this 9 goes to the other side, dividing, and I get 9 over 9. How much is 9 over 9?
1.
1. So y is 1. Now I'm substituting this value of 1 into my new equation, 1 in this case. Then I'm going to have x is equal to 2 instead of y. I'm using the one that I found plus 1. 2 times 1. 2 times 1.
2. 2.
And 2 plus 1.
3.
3.
3. So I found my solution. I have one solution as well. And what is the solution in here?
3,1.
3, comma 1. It is a coincidence that both exercises that we showed were one solution. Now, how would you have infinitely many solutions? Okay, just an example of how you would get infinitely many solutions. If you get, for example, 0 equals to 0, that is infinitely many solutions. Okay, or you get 1 equals to 1, that is infinitely many solutions. Okay. How do you get a no solution? If you get 0 equals to 2, or you get -1 equals to 5. 0 is not equal to 2, and -1 is not equal to 5. Therefore, if you get something like that, that is not true, you just go ahead and say no solution, okay? That's how you will know if you have infinite limiting solutions or no solution at all. If you get a value of X and a value of Y, then you have a one solution, okay? And the solution is X comma Y, the order pair called X comma Y. Okay, so what is the topic's name? What do you think is the topic's name? What is the topic's name? What did we just solve? We solved what? What is this?
Equations.
Huh?
Equations.
Yeah, they're equations, but when there are two equations together, they are, no, it's not combined equation. There are two equations, they are called, what did we solve the last week? Solved what? What did we solve? Solving
Solutions.
systems. And
Like
what did we
graphing.
use? What did we use?
By substituting.
Exactly. So solving systems using substitution. Okay, that is the topic for today. Solving systems using substitution. Missed an S in here. Substitution. Now next, that we're going to see is the very last method of how to solve a system. It is not substitution and it is not graphing, okay? And that's what we're going to be seeing next class.